Hey people, and welcome to this video. In this video, we will be working on the grade 12 mathematics paper 2 for November 2024. So this paper is worth 150 marks and the time allocated is 3 hours. Okay, so looking at the instructions, just remember to round off to 2 decimal places unless stated otherwise, and the diagrams are not necessarily drawn to scale. With that being said, let's get into this video. Question 1 says, at the beginning of a season, the coach of a junior boys rugby team recorded the weight in kilograms of 15 players in his team and the number of push-ups that each player was able to do in 1 minute. The data is represented in the table and the scatter plot below. The least squares regression line for the data is shown. Okay, so you see they give us two pieces of information. They give us the information as a table and also in the scatter plot. So we don't have to plot anything here. So question 1.1 says, determine the equation of the least squares regression line for the data. Okay, so we know that the equation of the least squares regression line, that looks like this. It's the equation of a straight line. Y equals A plus BX. And all we have to find is the A and the BX. So this is a bivariate data set. So we're going to put the information down in our calculator. Now, you'll be using a Casio calculator, but you can still follow the steps. So start by pressing mode, and after pressing mode, you're going to see a couple of options, and you need to go for option 2, which says stat. And then when you go for option 2, you're going to see that option 2 here will have A plus BX. So go for that option. And when your data shows up like this, make sure to put in the X values and the Y values. You can ensure that they're put in correctly because on your calculator on the side, there will be numbers. So you have to ensure that you do end at 15 numbers for each column. And once you've recorded the data, then you can go ahead and press AC, Shift, and 1. And then you'll see 6 options, but you need to go for the option that says regression, which is option 5, REG. So go for that. And then remember, we are looking for the value of A and B. So after choosing that, you see that number 1 is A, and you can just find out what A is equal to. A would be 39 point, and round off to 2 decimal places, that would be 46. And then the value of B. So again, you can just press Shift and 1. I have to erase that. Shift and 1, and then find the value of B. So B is equal to negative 0.59. Okay, so now we can just fill that in our equation. So it means that the equation of the least squares regression line is 39.46 minus 0.59x, and that is our answer. The next question, 1.2, says write down the correlation coefficient. Okay, so the correlation coefficient will also be found where we find regression. So you can press Shift and 1, and then again go to number 5 for regression, and there's our correlation coefficient. It is R. So R is equal to negative 0. Now that's going to round up. You see that 7 will round that up, and then that adds a 1 to the 7. So that is 0.8. Okay, so negative 0.8 is our answer for the correlation coefficient. Question 1.3 says, the coach uses the least squares regression line to set the target for the minimum number of push-ups by each team member. Okay, so the least squares regression line is now what everybody has to meet depending on their weight, as you can see. So that would really mean somebody, for example, who weighs 30 kgs should be able to do this amount of push-ups, which if you go to the left, looking at that over there, that's about 22 push-ups. Okay, so that's really what they're saying. So we already have the equation of the least squares regression line, so that will help us here. Okay, so the coach is using the least squares regression line to set the target for the minimum number of push-ups by each team member according to their weight. Predict the number of push-ups that a member of the team who weighs 29 kg should do to meet the target. Okay, so we already have the equation of the least squares regression line. Instead of looking at that line, we're going to use the equation. And we know that this person weighs 29 kgs. So you can see that the kgs are the x values. So in place of x, we'll substitute 29. So this is this. And we have y equals 39.46 minus 0.59. And in place of x, we say 29. And let's go ahead and find out what that gives us. And that gives us 22.35. Okay, so that's actually about 22 push-ups, but you can't leave it like that. And that is our answer. Question 1.4 says, write down the mean number of push-ups for the given data. So the mean number of push-ups. Remember that the push-ups are your Y values, okay? The weights in kgs, those are the X values. So to find that, we're going to use our calculator again and then press Shift 1. Okay, so after pressing Shift 1, this time we are going to go for VAR. Okay, and when you go for that, go for the option that says this. You're looking for the mean of the Y values, since this is a Y value. Okay, and you see that that is that over here. Make sure not to take this one. Okay, it's the one with the line on top. That's the mean of the Y values. And we get 18.33. Okay, so on average, everybody did about 18 push-ups. Okay, and that is our answer. Question 1.5 says, the players trained hard during the season. At the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of the season. How does this increase in the number of push-ups influence the standard deviation of the data? Okay, so let's speak about standard deviation and what it really does. Okay, we're looking at the standard deviation of the Y values. You see how the push-ups, the mean push-ups was 18, right? So let's just look at it graphically. So if we look at it like this and we say that the mean push-ups was 18, right? That was the mean of the Y values. It's about 18. But now everything increases. So the rugby players would have gotten different values, okay? Different push-ups. Some got higher than others, some got lower, okay? And what happens is everybody increases by 5, okay? So every push-up here increases by 5. So the push-ups are going to increase by 5. So they will not be 18 anymore. There will be 5 more than this, which is 23. Okay, so you have a new mean value that will be there. So everything else would also increase. It goes from here and then it pushes up. But let's look at how this affects the standard deviation. You see, the thing about the standard deviation is you need to understand what it actually measures. The mean measures the average of all the points. It takes everything, adds it up together, and divides by the number of points that you have. The standard deviation is somewhat of an average as well, but it's really like an average of the differences between the mean and each point. So it measures how far is the mean from this point, okay? And it measures how far is the mean from this point, and that point, and that point, and it will get an average of that. That's why we say it's a measure of dispersion. It measures how spread out your data is. So now you can think about it like this. If the push-ups used to be 18 on average, and then all these other push-ups were there, but then they increased by 5, okay? So meaning all of them moved together by 5, and then they went up here. Look at what that did to the spread of the data. Did it do anything? No, because this point will still be away from the mean at the same distance that it used to be. It didn't change. The difference does not change. This becomes 23, sure, but maybe this one used to be 20. Well, when it increases by 5, it's going to move up to 25. The difference between the mean and that point will still be the same distance. So these distance, they did not change. Okay, so what it does is it does not have an effect on the standard deviation, and that's going to be our conclusion. So the increase will not affect the standard deviation, and that is our answer. Question 1.6 says, at the beginning of the season, the coach used the least squares regression line as the minimum target for a player to aim for. Determine the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target. Okay, so that least squares regression line is now the minimum target. The coach is saying, everybody, depending on your weight, you all need to meet this, okay, as the minimum target. And so It really means that whole thing about when you have somebody who weighs 30 kgs, for example, they're expected to do this amount of push ups, which was about 22 push ups, and so on. So the main goal here is they're really just asking, determine the maximum possible increase. What is the highest possible increase in the number of push ups that a team member can obtain to meet that minimum target? Another way to really just see this is what is the biggest progress in the push ups that we're going to see? What is the biggest difference in push ups we're going to see? So this person here weighs about maybe 27 kgs, right? And this person can do 20 push ups. So they're supposed to be able to do about maybe 24 push ups, okay, or 23.5. Now, from the amount of push ups that they're able to do to what they should be able to do, it's not that big a difference, okay? So this person's progress is not that big. The increase that this person is going to have is really not that high from where they were currently to where they should be. Now, if you start looking at points that are much lower than this line, for example, and this one is actually really clear, this point over here, look at the increase this person has to really make to meet that cut, that minimum target. Currently, this person weighs 40 kgs and they can do about 6 push ups, but they should be able to, according to this least squares regression line, they should be able to do this amount of push ups. So, this, if you line this to this is about 16 push ups. They should be able to do 16 push ups. So, do you see that this person is going to be the highest increase we will have? That is the highest increase to meet that minimum target. So the highest increase we're going to see here would be this person should do 16. They can currently do 6. So that would be a difference of 10, 16 minus 6. So the maximum possible increase in the number of push-ups that a team member must obtain to reach the minimum target would be 10 push-ups. And that would be our answer. Okay, so the maximum possible increase would be 10 push-ups. Question 2 says the cumulative frequency graph, the ogive, shows the time taken in minutes for 60 employees to travel to work each morning. So we have the time in minutes on the x-axis and the cumulative frequency on the y-axis. And the first question is to estimate the median travel time. Okay, so to find the median travel time. The median marks the middle of your data set. So to find that, it's half of your data set. So the data set that we're working with is we have 60 employees. So to find this median, we're going to find the middle of 60 employees. So 60, and you're going to multiply this by a half. And this will tell you the position of the median. So this will be 30, meaning it's at the 30th person. Okay, this is the time and this is the people. So we'll go to the 30th person on the y-axis and then you go to the right until you hit the ogive. And it's really just in between here. So we'll just find out what exactly that number is. So these are counted in intervals of 2. So this would be 60, 62, 64, and then in the middle will be 65 since this is 66. Okay, so the median is about 65 and we can put that down. So the median travel time is 65 minutes and that's what we'll just leave there. Okay, moving on to the next question. The next question, 2.2, says estimate the lower quartile. Okay, so it's very similar to how we find the median. You see how the median is exactly half your data set? Okay, then the lower quartile will be a quarter of it. So 1 over 4. So that's how these go. So it's going to be 1 over 4 of your data set. So we will say, just like we said here, 60 times a half to find out the position of the median. We will say 60 times a quarter, 1 over 4. And that would be 15. So it's the 15th person. So on our ogive, on the y-axis, we go to 15. And we run until we hit the ogive and then we go down. So it looks like it hits around here. So we can just go down and this will be 42, 44. So that would be 44 minutes. That is our lower quartile. So we can tell them the lower quartile or Q1, because that is what we can call it, quartile 1, is 44 minutes. Okay, and that is the answer to that question. The next question, 2.3, says, estimate the interquartile range. Okay, and that is also called the IQR, interquartile range. And we find this like this. It is Q3 minus Q1. Okay, it's really the range of your quartiles because it's a range. So we know what Q1 is, we just found it. We need to find Q3. So you see the way we found Q1 by saying 1 over 4 times 60. Q3 would be 3 over 4 of your data set. So it would be here, okay? So we'll say 60 multiplied by, to find the position of Q3 first, this is just the position, and we'll say 60 multiplied by 3 over 4. Okay, so that's going to be 30 plus 15, which is 45. So we will find Q3 at the 45th person. So on your y-axis, you go to 45, and then we run until we hit the ogive. So it's around there. Let's just try to be exact. It's roughly here. Okay, and so that would be exactly 84. Okay, so yeah, that's what that is. So we say that therefore Q3 is 84, and now we can find the interquartile range. So IQR equals Q3 minus Q1. Therefore, the IQR is 84 minus Q1, which was 44. And so you can see that that is the interquartile range is 40 minutes. There we go. Okay, and that is our answer. Question 2.4 says the minimum and maximum times taken for an employee to travel to work are 5 and 20 minutes respectively. On the scaled line in the answer book, draw a box and whisker diagram to indicate the distribution of the data as represented in the ogive. Okay, so you see that they have given us everything. The minimum is 5, and we also know the value of Q1. We know that that is 44. We know Q2, which we know is 65, and Q3 is 84, and we know the maximum. So we have everything we need to draw a box and whisker diagram. Okay, so from the numbers that we have, you see that we have ones going in fives really. So you can choose numbers like, but it's going quite far. Okay, it's going to 120. So we can count in fives, but fives would be a little too small. So you need more numbers. So rather count in tens. That's fine. So we can follow the numbering of the answer book and just count in tens. Okay, so our whiskers are going to be our minimum and maximum. So the minimum is 5, but since 5 is not here, you'll put it here. And then you just write the number. It is 5, so we put it up there. And then we have the maximum at 120, and that is there, so it's 120. Then Q1 is 44, so that's about here. So 44 is roughly here. And so we'll draw the line down for 44. Okay, these dots should just go a bit higher. So 44 is here, roughly here. And then we're also going to write down 44 since it's not really written on the number line there. And then we have Q2, which is 65, which is right in the middle of 60 and 70. And we'll write 65. And then 84 is Q3. So that's about here, 84. And just make sure you write it down, 84. Okay, connect your quartiles and then connect the box. Connect them to the whiskers. So there we go, and there we go. So there we go. That is our box and whisker diagram. Moving on to the next question. Question 2.5 says, the company manager decided that all employees who travel for an hour or more will be allowed to work from home. Okay, so an hour or more. What percentage of employees will be allowed to work from home for part of the day? Okay, so we are looking for employees who work for 1 hour or more, and then we're going to find out the percentage that they make up. As you can see, this is in minutes. So we're going to look for 60 minutes and more than 60. So at 60 minutes, do you see that the amount that we get, oh, it seems like they really pointed it out. So it's this over here. And if you go to the right, it's about 26. You see, because that circle is above there. So it's about 26 here. And now to mark the employees who traveled for more than 60 minutes. This is how we're going to look at it. You see, everybody below here, these are people who traveled for less than 60 minutes. Because do you see that if you go from 60 all the way to here, then we get to 26. So a sum of these 26 people would be everybody who worked for 60 minutes or less than 60. And then the people above would be the ones who work for more than 60. Okay, so you know that there are a total of 60 employees. Then these will be people who work for more than 60 minutes. So that is 60 minus 26. Okay, so we'll just put that down, which is 34. So now we know it's a total of 34 people. But the question is, what percentage of the employees are allowed to work from home? So these 34 people, to put them as a percentage, we'll just say 34 over the total people, which is 60, times 100. And then we'll just find that answer. And that is about 56.67%. Okay, so that is the answer to that question. 56.67% of the employees will be able to work from home for part of the day. Question 2.6 says, employees work 8 hours in a normal working day. The manager decided on the following rule for the time to work from home. Okay, so they work 8 hours normally, and this is the rule. The rule is an employee is allowed to work half an hour from home for each time interval of 20 minutes or part thereof above an hour taken to travel to work. Okay, we're going to have to break that down. And the question is, on a certain day, an employee takes 110 minutes to travel to work. Calculate the number of minutes that this employee will be allowed to work from home on this day. So the minutes that they can work from home. Okay, let's look at the rule and understand what the rule is. An employee is allowed to work half an hour from home. So you can work half an hour from home for each time interval of 20 minutes or part thereof above an hour taken to travel to work. So in the previous question, the employees that took more than 60 minutes to get to work, they were allowed to work from home for a specific amount of time throughout that day. And now they're telling us the time that they get to work from home is exactly 30 minutes. But this is going to be, you get to work from home for 30 minutes for each time interval of 20 minutes. So here's the thing. They are already going to work from home if it takes them longer than 60 minutes to get to work. Now, each 20 minutes above this, and they say all part thereof, okay, or part of that 20 minutes. So each 20 minutes above this, you get to work from home for 30 minutes, okay? So we're looking at this as, this is, you took 20 minutes extra, okay, or 20 minutes more than the 60-minute requirement. Then you're going to get to work from home for 30 minutes, okay? The employee in question takes 110 minutes to travel to work. So we'll start counting from 60. This employee takes 120 minutes. Okay, so 60, and then if you add 20 minutes, then we will be at 80 minutes. We're still not at 110. Let's keep going. Another 20 minutes because this employee worked for 110 minutes, so we're counting in intervals of 20. Another 20 minutes would leave us at 100 minutes, okay? Almost there. This employee worked for 110 minutes. So this is going to be 10 minutes extra. But remember what they said, a part thereof. Okay, so 10 minutes extra as well. So for every 20 minutes this employee spends extra to get to work, this employee will be allowed to work for 30 minutes from home. So they get to work for 30 minutes because they passed the 60. Then we have another 20 minutes that they spent traveling. So you get to work for 30 minutes from home again. And then another 10 minutes. Remember, they say all part thereof. So it doesn't have to necessarily just be 20 minutes. But even if it's a part of 20 minutes, you still get rewarded to work from home for 30 minutes. So in total, do you see how much time that is? 30 plus 30 plus 30. That is a total of 90 minutes. So this employee is going to work from home for a total of 90 minutes. And that is answer to this question. Question 3 says, in the diagram below, triangle ACD has vertices A, D, which we can see over there, and C, where A is a point in the second quadrant. Then they tell us that B, -1, and K lies on DC. And the first question is to calculate the gradient of DC. Okay, you can see that we have both points, so we can find the gradient by saying the gradient is equal to, and we have the gradient formula. And then we can say d minus c. So the d value is minus c, which is negative 9 minus 0 all over 3 minus negative 9, which becomes a plus 9. Okay, so this is equal to negative 9, and that would add up to 12. So that is equal to negative 3 over 4. It simplifies to negative 3 over 4. And that is the gradient of DC. Moving on to the next question. Question 3.2 says, determine the equation of DC in the form of y equals mx plus c. So we already have the gradient of DC. So this is going to be y equals, and our gradient is negative 3 over 4x plus c. And we can just substitute 1 point on DC. You see that c is an easier point, negative 9 and 0. So the y value is 0, the x value is negative 9. So substitute negative 9 and then plus c. So let's find out what that is first. So this will give us 27 over 4. So we can take it over and it's negative. 27 over 4 is c. And so therefore y is equal to negative 3 over 4 x minus 27 over 4. And that is the equation of line DC. Question 3.3 says, show that k is equal to negative 6. Okay, so you see that k was one of the coordinates, the y coordinate, on the line DC. We now have the equation of DC, so we can substitute this as the x and y value in this equation. So we're taking this and we will substitute x and y, and we will find what k is like that. So that's negative 1 and k, meaning the y value is k, and we have negative 3 over 4, negative 1 minus 27 over 4. And so this will give us the value of k. So k is equal to, and then we'll just find that. And the answer here is, that's going to be 3 over 4 minus 27. 3 minus 27 is 24. So 24 over 4 is 6. And remember, it's going to be negative because that's 3 minus 27. So that is negative 6. And indeed, k is equal to negative 6. The next question, 3.2, says, calculate the length of DC. So we just need the distance formula, which is this. And then we just need the coordinates of DC. So D is 3 and negative 9, and C is negative 9 and 0. Okay, so DC is equal to, and we'll say the square root of, and we can just follow an order. So top minus bottom is fine here. So we'll say 3 minus negative 9, which becomes a plus 9 all squared, plus negative 9 minus 0 all squared. And we'll find out what that is. And that is equal to 15 units. So DC is equal to 15 units. And that is our answer to that question. Question 3.5 says, calculate the ratio of dB over DC. We already know what the length of DC is. So if we find the length of dB, we'll be able to do this. Okay, so we know what D is now, and we also know what B is because B is filled in. Okay, so something that you can always just do is update this. So you have negative 6 over here, and you know that DC is exactly 15 units. And now we can just find dB, and we don't really need the distance formula since we already had it. So say square root of, and we're saying x2 minus x1. So we can go 3 minus negative 1, which is plus 1, all squared, plus, and then we have negative 9 plus 6 all squared because of the double negative that we get there. Okay, so let's find out what exactly dB is. So dB is equal to 5 units. Okay, and now we'll be able to find what dB over DC is. So therefore, dB over DC is therefore equal to 5 over 15, which is just going to simplify to 1 over 3. And that is our answer. Okay, so moving on to the next question. Question 3.6 says, if M is a point on AD such that AC is parallel to MB, calculate the ratio of triangle MBD over triangle ACD. Okay, so here is our diagram, and they're telling us that M is now a point on AD on this line in such a way that AC is parallel to MB. So this is parallel to MB. So M would be somewhere here, right? Let's say we have M over here, and they're saying that if we connect this, then these two lines are parallel. Okay, with that being said, we need to calculate the ratio of these triangles over each other. Let's look at those triangles and see what we have in each of them. So remember that we already have BD. We already know that this is 5 units. So let's just keep that in mind. If we know that, then triangle MBD, as you can see, is this triangle over here, and ACD is the bigger triangle. So to be able to find those ratios, we would need to ensure that we have the sides. Here we've got the side in DC. DC is fine. It's looking good. We have 5, we have 15. But do you see that in DA, we don't really have anything. This DM and that's DA. We don't have anything there. But we can get some ratios there by using the proportionality theorem. Now, this is analytical geometry, so we don't really need reasons. So we can simply just tell them that DM over DA, see how we took this little side over the bigger side? So you have to do the same thing with this line. So you're taking DB over DC. Okay, and we're saying that the ratios are equal. So that would mean that what we're looking for with the DM over DA is actually equal to 1 over 3. Because we knew what DB over DC was. It was 1 over 3. That ratio gave us 1 over 3 in the previous question. So we know that. And so what this means is that this over here, it's going to get 1 part of whatever the length of that line is. It has a ratio of 1, meaning we can call that A, and then we can call DA, we can call that 3A, meaning this gets 1 part and that gets 3 parts when we know the length of the line. Okay, now that both sides actually have lengths or ratios, we can find the areas. So they specifically want the area of triangle MBD over the area of triangle ACD. So to find the area of triangle MBD, you can see that we don't have any perpendicular heights. So we are going to use the trigonometry method of finding the area. So this is a half multiplied by, we'll focus on angle D as our center angle. So it's a half multiplied by the side next to it. So we'll say multiply by DB, and then multiply by DM, then sine of angle D. And they will both have sine of angle D, and that's really what we're trying to go for. And this goes over in the bigger triangle ACD. This is a half multiplied by DC, and then multiplied by DA, sine of angle D again, because that is also the center angle. Okay, so if you fill these in and you have a half times DB, you can see that DB is exactly 5 units, and DM is A, but it's fine. It's a ratio. You can leave it as 1 if you want, but just to show you what happens, even if it was just the ratio, we were saying it took 1 part of whatever the length of the line was, it would still work out here. And then we'll say sine of angle D, which we know will cancel. And we could have already canceled it from this point. Likewise with the half. So we do not need to even write this half. So we have a 5 times A, and then over DC is 15 units. And we'll multiply them by 3A, that is DA, 3A. So do you see what happens here? The A's will cancel because it's just the ratio. It's that ratio over that ratio. So it still gives you that 1 over 3 that you're looking for. So 5 over 15 also gives you 1 over 3. And A over 3A is also 1 over 3. So do you see that when we multiply, that's going to give you 1 over 9. And that is the ratio of those two triangles being put over each other. Okay, so that is that answer. Question 3.7 says, if it is further given that the gradient of AD is -4 gradient of AD, and the length of AD is the square root of 612 units, calculate the coordinates of A. Okay, so with AD, they're giving us information about its gradient and the length of the line. How can we use that to find A? Well, right now this point A, because it doesn't have any coordinates, we can really just call it X and Y. So if we had an X and a Y value, and we said we know what the distance of this line is, and we tried to find the distance of the line, and we could equate it to the number that it's equal to, that square root of 612. We could actually find this, but the only problem right now would be this equation, it's going to form an equation, but it needs to be in terms of one thing. Okay, it's better for it to be in terms of x. So it would be in terms of x, yes, because of this x, but unfortunately right now there's a y. So that is the problem right now. We need an expression in terms of x to represent the y value of a. Okay, so how can we do that? That is probably why they gave us the gradient of the line. We could find the equation of AD. We have 1 point on AD, we've got D. So let's go ahead and do that. So long the gradient is -4. Okay, so we can just say, and I'll use this formula, y minus y1 equals the gradient, which is -4, times x minus x1. Okay, then we can substitute the 0.3 and -9 because it lies on this graph. So this is y minus y1 and x1 is what gets your coordinates here. So y1 is -9, so minus -9, which gives you +9, is equal to -4, x minus 3. Let's distribute. So this will be -4x positive 12, and then the 9 will come over and become negative. So y is finally equal to -4x. 12 minus 9 is 3. So this is the equation. And this is what we can actually call this point A. Because its equation is y equals -4x plus 3, we can say so long the x value is just x, and the y value, because we say y is equal to, this is the y value, the output, in respect to whatever the input is. So that will take on the y value, so plus 3. And that's what we can call that. So great, they're both in terms of x. And now we can use the distance formula. So let's put that formula down. And it's the distance of AD. Since they gave us the distance of AD, it's the square root of 612 units. So in place of AD, you can say it's the square root of 612 units. And then we will substitute the x and y values. Okay, in this case, it's better to say top minus bottom so that the x's stay first. So it's the square root of, and right away you can as well just get rid of this square root. So square both hand sides because it's going to be in the way when solving for x. So AD squared is, since this is 612 and it gets squared, it's just 612. So 612 is equal to, the root is broken open now, and now we'll say x2 minus x1. So that's going to be x minus 3 all squared, and then we're saying plus, and this is, and I said 4x here, it should be -4x because that's what we got. So it is -4x plus 3 minus -9. Okay, so that becomes a +9 all squared. And we just have to solve for x in this equation. Okay, we might as well just start by distributing. So we still have 612. And then here we have x squared, and then square the last term, which is +9. First term times second term is -3x, times 2 is -6x. Then same thing happens here. Okay, we can just look at the fact that they would have added and they will give you +12 all squared. Okay, so first term all squared is +16x squared. Last term squared is +144. And then first term times second term gives you -48x times 2 is -96x. Okay, so now we can just simplify this. We have 17x squared, so 17x squared, and we'll just take that over already. And then these two subtract. So that's going to be -102, -102x, and then these two. So added together, they give you 153. But remember that 612 comes over, so giving you -612. Okay, so we can just rewrite here. Therefore, 0 is equal to 17x squared minus 102x. And when we subtract, let's just see what that gives us. 153 minus 612 is -459. -459. Okay, hopefully they're all divisible by 17. So let's just see. We can divide both hand sides by 17 already. Okay, because they're probably, but we'll just see. So that would be x squared. If this is divisible by 17, 102 divided by 17. Okay, it is. So that's negative 6x. And then 459 divided by 17 is 27. So negative 27. Okay, so this is what we have. And now we can solve for x. So 0 is equal to, open up two brackets, x times x is what gives you x squared. And then we need factors of 27 that can give us a negative 6. We can try negative 9 and 3. Okay, so if you add them together, they give you negative 6, but multiply, they give you negative 27. So that's it. We have positive 3 and negative 9. Okay, so that therefore means that x is either equal to negative 3 or x is equal to positive 9. Now, based on our diagram, and seeing that A is in the second quadrant, then the x value is negative. So x is equal to negative 3. Okay, so we're not going to use this one. So we can just say this is not applicable. And then we can say y is equal to find the y value. Okay, because we need the full point. You know that the equation of the line AD is y equals negative 4x plus 3. So that's y equals negative 4. In place of x, we say negative 3 and then plus 3. And that would be 12 plus 3, which is 15. And so therefore, the point A we were looking for is simply negative 3 and 15. And that is our answer. And that is it for question 3. Question 4 says, in the diagram, M is the center of the circle. The circle cuts the x-axis at N, and they also tell us that ST is a tangent to the circle at P. Okay, so that is a very important point to note. Then R, which is D and 1, with D being greater than 1, as we can see on the positive part of the x-axis, and L lie on the circle. So these are just points on the circle. O and V are the x-intercepts of line PL and RL, respectively. And the first question is to write down the coordinates of L. Okay, so you can see where L is. L is on the circumference. And what do we know about this line that is connected to N? This is a diameter, and we have been given the center already. So we can use the midpoint formula, okay, to find this. So we are saying we are finding the midpoint of this line. So, and here's the formula to find the midpoint. Okay, so because you're finding the midpoint, these are your endpoints, L and P, meaning this, it's just X and Y for now. This is X1, that's X2, that's Y1, and that's Y2. Okay, so we're saying X plus 3, and that's X plus 3, and then over 2, and then the Y's, that's Y plus 9 over 2. And we're really just trying to find the midpoint of LP, which is M. But the thing is, we already have M. So in place of this M, the midpoint, we're going to put down the coordinates of M, which is 1 and 3. So this is 1 and 3. So on one hand side, you have the actual midpoint, M. And on the other hand side, we have the calculation for the midpoint. So they're really the same thing. So what we're going to do is equate their X values and equate their Y values. So we're saying 1 is equal to X plus 3 over 2, and 3 is equal to Y plus 9 over 2. Okay, so now we can just solve for X and Y. So here, to get rid of this 2, to get closer to the X, we can just multiply both hand sides by 2, or you can see this as cross multiplying. So we multiply 1 times 2, which gives you 2, and then the invisible denominator of 1 times this stays exactly the same. So therefore, X is equal to, this is 2, and the 3 comes over, so we have negative 1. And then the Y here. So again, we can cross multiply, so this will be 6, and we still have Y plus 9, and we're saying Y is equal to 6 minus 9, which is negative 3. So that means that that point that we're looking for, L, is actually negative 1 and negative 3. So L is negative 1 and negative 3, and that is our answer. Question 4.2 says, determine the equation of the tangent ST to the circle at P. So what do we know about this tangent, ST? How can we find its equation? Well, there's only one point on it. Despite the fact that there's only one point on it, do you see that there is a radius that intersects with this tangent? And we know from Euclid that a radius and a tangent are always perpendicular at their point of contact. So we have a case of perpendicular lines here. So if we find the gradient of the radius, we can use that to find the gradient of the tangent. Okay, so we're using M and P. So the gradient of MP, the radius, is we don't really need the formula since we've already worked on this on gradients already, and you don't get a mark for the formula. So we can just go ahead and say y2 minus y1. So I'll say 9 minus 3 over 3 minus 1. Okay, so there you're going to get 6, and here you're going to get 2. 6 divided by 2 is 3. So the gradient of MP is 3. Now, if you know the gradient of the radius, this is how we find the gradient of the tangent. The tangent was ST, right? It's really just going to be this, and you're going to switch the numerator and the denominator. The natural denominator is 1, so if you switch it around, it's 1 over 3. Then you multiply it by negative 1. So this follows the rule that the gradients of two perpendicular lines work like this. The gradient of the one line multiplied by the gradient of the second line will give you negative 1. So to find the first gradient, we say negative 1 divided by the gradient of the other one. That's why we switch it around and times by negative 1. So this is going to be equal to negative 1 over 3. And that is our gradient so long. And now we can find the equation. Okay, so we've got the gradient, and you see that on this line we have the point P. So let's substitute 3 and 9, okay? And so this is going to be y minus y1. This is p, that's x1 and y1. So y minus 9 is equal to your gradient and then x minus 3. You can use y equals mx plus c, that's also fine. So this is going to be equal to, and we'll distribute. So that's negative 1 over 3x. And when we distribute that, it becomes positive 1. And then take the negative 9 over to become positive 9. So we have positive 10. So y is finally equal to negative 1 over 3x plus 10. And that is the answer for 4.2. Question 4.3 says, show that the equation of the circle with center M is this. Okay, so after finding the equation, they distribute it and put it in this form. Okay, so you would need to know the general form of a circle. An equation looks like this. It says x minus a all squared plus y minus b all squared is equal to r squared. Okay, and these would be our center. So that is the middle, the center of the circle. And then x and y just open for x and y values. So looking at our circle, do you see that they gave us the center? And we already have 2 points, so we can just use the center and this point. So the center is M, which is 1 and 3, and let's just put that down. And M is the center, so that is A and B. So we'll say x minus A, which is 1, all squared plus y minus 3, all squared, is equal to r squared. Okay, so do you see now that this equation is almost complete? The only thing missing is r squared. So we can substitute this point in place of x and y since it lies on the circle so that we can find r squared. So this is going to be, we have 3 minus 1 all squared plus 9 minus 3 all squared, and that gives us r squared. Okay, so 3 minus 1 is 2, 2 squared is 4, and 9 minus 3 is 6, 6 squared is 36, 4 plus 36 is 40. So this is 40 equals r squared. And now that we have r squared, we can just substitute it into the equation that was almost complete. You just needed r squared. So this is equal to 40. Okay, and now do you see the format they put it in? So we need to distribute. So distributing this, we will say the first term squared, which is x squared, and then the last term squared, which is positive 1. First term times second term is negative 1 times 2 is negative 2x. And then same thing over here. First term squared is y squared. Last term is positive 9. 2 terms multiply and then times 2, which will be negative 6y. Okay, and this is what this looks like, is equal to 40. But you can just take the 40 over. So it's equal to 0. And now we can write it in their order, which is x squared, and then we have plus y squared minus 2x minus 6y, and we have 9 plus 1, which is 10, and 10 minus 40 is negative 30, is equal to 0. And that is the answer. So just like they have it there, and that is 4.3. Question 4.4 says, show that D equals 7. Okay, so D in our diagram is over here. Okay, do you see that it lies on the circumference of the circle? So that means we can substitute it in place of x and y. So this is our x and that's our y value. Okay, so this is our x and our y value, and we'll just say D, which is x, so that's D all squared, plus 1 squared minus 2 times D, so that's just minus 2D, minus 6 times 1, and then minus 30 equals 0. And we just solve for D. Okay, so we have D squared and then minus 2D, and then these just add. So 1 minus 6 is negative 5, minus 30 is negative 35, is equal to 0. And then we have to factorize. So open up two brackets, and we're saying D times D gives you D squared. And then we need factors of 35 that can give us a 2. So 35, we can say 7 and 5. 7 times 5 is 35. But one of it needs to be negative. But you need to ensure that the middle stays negative. So give the negative to the bigger factor, and then that stays positive. Okay, so that therefore means that D is equal to 7, or D is equal to negative 5. Okay, based on where D is supposed to be a positive number. Okay, so D is greater than 0, so you can also just tell them that, but D is greater than 0, so therefore D is equal to 7, and that is our answer. We are now on question 4.5, and question 4.5 says, calculate the size of angle L. Okay, so let's see where angle L is. Angle L is over here. Okay, and do you see that the lines that create angle L, we actually have the coordinates of those lines. So angle L is created by the line LR, which we have the coordinates of, and line LP, or we can say LM. Okay, so here's how we can create this angle. First, we can start by drawing an imaginary x-axis. Okay, so it is parallel to the actual x-axis, and then you can push it down to the point where angle L was formed. Okay, so to that point over there. And now we can see how angle L was created. Do you see that if we take this angle, so from the imaginary x-axis to this line ML, and you take that entire angle and you subtract it by the angle created with the x-axis to this line angle LR, do you see that you're going to be left with angle L? And that's what we want. So we're going to use the angle of inclination. We would have to say, to find angle L, we'll say the angle of inclination of this line ML, that bigger angle, minus the angle of inclination of the line LR, and that would give us angle L. Okay, so let's go ahead and do that. So along with that, we'll need these points M and L, R and L. Okay, so basically like this. Now we just need to find out if we have any of these gradients already. So let's look, do we have ML and do we have LR? Do you remember that initially we were trying to find the equation of a line? We used this gradient MP, which was 3. Now do you see that on our diagram? Do you see that MP is the gradient of ML? Because they are collinear, they lie on the same line. So we already have ML, it's 3. We already have that gradient, and we can just put that down. So the only thing we need to find is the gradient of LR. So the gradient of ML is equal to 3. Okay, let's find the gradient of LR. That's all we need to find. So we'll say y2 minus y1 over x2 minus x1. Okay, so we don't really need M. Okay, so we're looking for the gradient of LR, and this is equal to, we'll just say top minus bottom since the tops are negative. So that's negative 3 minus 1 all over negative 1 minus 7. Okay, and that's going to be negative 4, and negative 8, and you see that that would give us a half. Okay, so we know the gradients now. Now that we know that, we can just apply this rule over here. You see, to find the angle of inclination of ML, we simply use the formula tan theta equals whatever the gradient of ML is. So tan theta equals 3, because that's the gradient of ML, 3. And then to find theta, we'll say theta is equal to, and to cancel tan out on both sides, we're going to use the second function of tan. You can also see this as taking tan over, and so tan becomes the inverse of what the tan function does. So it is shift tan or arctan 3, and let's just leave that like that so that we don't have to round off. Okay, so the gradient of ML looks like this, and then the gradient of LR would look like this. Tan theta equals whatever the gradient of LR is, which is 1 over 2. And so theta of LR is equal to shift tan of 1 over 2. Okay, so we'll keep this now on this side, and now we can finally just find that angle. Okay, so let's go. So we are saying angle L is finally equal to, so it is shift tan 3 minus shift tan 1 over 2. Then angle L is equal to, and we can just find that on the calculator. And angle L is equal to 45 degrees, and that is our answer. Okay, moving on to the next question. Question 4.6 says TR. Okay, here is our diagram. PT is perpendicular to RT. That's what we have to prove. Okay, so we have a tangent now, TR. So that goes like that. And you have to prove that PT is perpendicular to TR. That's what we need to prove. Okay, what do we have so far? You see that here, we know that these two are perpendicular. So we can connect these two together. And if we can show them that these two are also perpendicular, it would mean that the opposite sides here are parallel, which is what we need. Okay, so do you see that MR is a radius because it goes from the center to the circumference? And they told us that TR is a tangent. You know that the radius and the tangent are perpendicular at their points of contact. So yes, we do have a case of perpendicular lines. Now, if you have opposite angles being 90 degrees like that, then yes, that indeed proves that this line is parallel to this line, and this line is parallel to this line. So instead of finding T, we'll take that gradient of TR that we needed to prove that the lines are perpendicular. We will use the gradient of PM, which we have. That was 3. So the gradient of TR is equal to the gradient of PM or MP, which is 3. And then we also need this gradient, MR. And so the other line that we were looking for, PT, the gradient of PT, well, this doesn't even need to be parallel, because do you see that we already have the gradient of PT? Since we have the gradient of ST, they are collinear. So that's equal to the gradient of ST. Okay, now what is the gradient of ST? We already found that like in the beginning. It's one of the first questions that we did. So here, the gradient of ST is negative 1 over 3. So we can put that down. That's negative 1 over 3. And now, because we have the gradient of TR or RT and the gradient of PT, we can show them that they are perpendicular. For lines to be perpendicular, when you multiply their gradients, you get negative 1. So the gradient of, let's call it RT, multiplied by the gradient of PT is equal to, so RT is 3 and PT is negative 1 over 3, and that is indeed equal to negative 1. So that therefore means that their gradients multiplied really do give us negative 1. So therefore, line PT is indeed perpendicular to line RT, and that is our answer. Question 5.1 says, in the diagram, OP is given with P being negative 3 and negative 4, and then we have KOP is equal to A. Okay, so without using a calculator, determine the value of cos A. So we first need to find the other side that is missing. So we're going to draw a line to the x-axis, and remember that this line is perpendicular to the x-axis. So this is your x value and that is your y value, meaning the x value, for you to have gotten that point, you went from here and you said -3 and then -4. So this is -3 over here and this is -4. So all we need to find is OP, okay, which is the hypotenuse. So we can go ahead and find that by saying OP squared is equal to, and using the theorem of Pythagoras, it's the longest side, okay, it's the hypotenuse, so we'll say -4 squared plus -3 squared, and therefore OP squared equals, that's going to be 16 plus 9, which gives you 25, so 25, and then we square root both hand sides. When we square root both hand sides immediately, remember you have to include the positive and negative solution. You have to consider those. But OP is a length, okay? It's a radius, so it's a length. So OP is always positive, meaning OP equals 5 units. And now we can find cos A, because we know this is 5. So cos is, using SOHCAHTOA, the directions we're going to go is adjacent over hypotenuse. So cos A is equal to the adjacent side, adjacent this angle would be -3 over 5. So that is -3 over 5, and that is our answer. Question 5.1.2 says we have to find the value of cos 2A. So cos 2A, we need some sort of double angle expansion for this. Now choose one that would be simpler. Do you see that you have cos A already? So just choose one with cos A so you don't have to find any extra thing. So we'll say cos 2A is equal to, and we can change it to cos squared A minus 1. Okay, so cos 2A equals 2, and then we are inputting cos A, which is -3 over 5, -3 over 5, all squared minus 1. Okay, and let's just find the value of that. And that is equal to -7 over 25. And that is the answer for 5.1.2. And then 5.1.3 says, find sine A minus B if it's given that sine B is equal to 4 over 5 and B is greater than 90 degrees but less than 360 degrees. Okay, let's find where this is. Now also note that the radius, okay, because that's the hypotenuse, sine is opposite over hypotenuse. The hypotenuse is also 5, just like the hypotenuse in the diagram that we have. So let's go ahead and find this. Sine is 4 over 5, meaning that sine is a positive number. So sine is positive in that quadrant, and it goes from 90 degrees to 360. So sine is positive in the first and the second quadrant. But since this goes from 90 degrees to 360 degrees, then it means it is in the second quadrant. So we have a radius that will be there, and its radius is 5 units. Okay. And we can see that the opposite side is 4. Okay, so it fits perfectly with this one. Okay, because you have those two sides equal, then this is 4. Okay, so that just goes -4 and that's +4. It means that they have a common adjacent side, which is -3. If you use Pythagoras again, you get the same thing since you're using 5 and 4. Two sides are already equal there. Okay, but now we have B. This is not A anymore, this is B. Okay. So we have the diagram down, and then finding sine A minus B should not be a problem. Okay, sine A minus B. What can we use to expand this? Because we don't know what their angles are. We can use the compound angle formula's expansion for this. So this is going to be sine A cos B, and then the sine stays the same. Cos A sine B. Okay, so we're just substituting. What is sine A? Okay, we don't have it here, but it is here. So the opposite over the hypotenuse. So of A, which is the diagram we already had. So that would be over here, sine -4 over 5. Okay, so that is -4 over 5 multiplied by cos B, which we don't have here, but if sine B is 4 over 5, then cos B is -3 over 5, because the other side that we had was -3. Then minus, so these two are together and they multiply minus, and we have cos A. Cos A is negative 3 over 5. Okay, negative 3 over 5. And then we'll put that down as well. Negative 3 over 5. And then sine B, which we already have here. It's 4 over 5. So multiply by sine B, 4 over 5. And we just have to multiply those and get our answer. Okay, but from this we can already see these will be positive. It becomes 12. So 12 over 25 minus a negative, also 12 over 25, same thing. Okay, but it's negative 12 over 25, so that just becomes a plus 12 over 25. 12 plus 12 is 24, so the final answer is simply just 24 over 25, and that is our answer. Question 5.2 says, if cos alpha is equal to P, express the following in terms of P. Okay, so you see that what we have is cos alpha over 2 minus 45 degrees sine alpha over 2 minus 45 degrees. So we have a repetition of the angles here, which is good. Now, do you see that this looks a lot like the double angle expansion for sine 2a? The double angle expansion for sine 2a looks like this. It says 2 sine A cos A. So it has that sine of an angle cos of the same angle flow. Okay, here we can see that. So we can just make sure that sine A and cos A are the subject. If you did that, you would have to divide both hand sides by 2. If you divide this by 2, you end up with sine 2A over 2. And we can just use that here. Okay, so here in place of cos alpha over 2 minus 45 degrees, we can say that that is just equal to sine 2, and then our A is the angle that was repeated. So that's sine 2 times alpha over 2 minus 45 degrees. Okay, and that goes over 2. Now we still have that. So this is just this part. And then we're still dividing by 2. So we can divide by 2 like this instead. If you say divided by 2, okay, it's dividing by 2 over 1. So we can use the rule tip and times, meaning you change the division to a multiplication and you swap the numerator and denominator. So this is what we have. So this is equal to, and we'll have sine, and we can distribute here because this is the number that multiplies into the angle. So this is going to be sine, and those multiply and become alpha, and those multiply and become negative 90 degrees over, and you see that it's just numerator times numerator, denominator times denominator, so that becomes over 4. Okay, so this is what we have, and our goal is really just to get a cos alpha, because that's the only thing we can express as P. We have negative cofunctions here. So I'm just going to work on this on the side, just so that you can see what it expands to. You can, however, study what the expansions of negative cofunctions would look like. So this is really sine of alpha minus 90 degrees. And how we expand this is you don't just take out the negative and say, it's just going to change. That can be very dangerous for certain functions that you work on here. So what actually happens is, because our angle is ultimately negative, okay, because this represents an acute angle, and then you have minus 90 degrees. So it's ultimately negative. And what we do when an angle is negative is we add 360 degrees to make it positive so we can better understand it and simplify it. So this would be equal to sine, and you know that 360 minus 90 is 270. So now you have 270 degrees and still a positive alpha. Okay, so this is what we have. Now, to simplify this, what we can do is it still has a 90 degrees. So we're still using cofunctions. We won't forget that this is still using cofunctions. So we'll rewrite it like this. Sine, and we'll separate 270 degrees as 90 degrees plus 180 degrees. That's what gives you 270, and then plus alpha. Okay, so now that it looks like this, you can group these two together. So if we group them together, this now becomes, we are looking at it as sine of 90 degrees plus an angle. When we say sine 90 degrees plus an angle, this ends up being cos A, okay, of that angle. So this is going to be using cofunctions. So cos of that angle, which is 180 degrees, plus alpha. And if you simplify this using your reductions, this becomes negative cos alpha, since 180 degrees plus alpha is in tan's quadrant. So do you see how that becomes negative cos of alpha? So we don't have to actually write all of that, because that is a rule that you should know by memory. So that is negative cos alpha over 4. And remember, they told us what cos alpha was. It is equal to p. So in place of cos alpha, we'll input p. So this is actually negative p over 4. And that is our answer. Question 6.1 says, given the identity cos, and we have the identity of cos x minus y, and we have to use the compound angle identity given above to derive a formula for cos x plus y. Okay, so using the rules used here, if cos of an angle minus another angle is equal to cos of that first angle, cos of that second angle, and they're being multiplied, and then the sign changes to a plus, and then sine that first angle and sine of the second angle. So we have to use that rule on this. Okay, so we have cos x plus y, and we need to expand this. So looking at this, how do we get this cos x plus y to look like that? To have cos of an angle minus another angle. We can do that by taking out a negative. So we can say cos, and this is x, and this now becomes minus negative y. That's the way we can do that. And so it still maintained what it originally was. It's still cos x plus y. We've just changed the way it looks. Okay, so these are our angles. And now we're just going to follow what that said. You see how this said cos of your first angle? And our first angle here is x. And the second angle is negative y. Let's just keep that in mind. So we'll say we expanded to cos of our first angle multiplied by cos of our second angle, which is negative y. And then the sign should change because the middle is negative. So we're following that. And then sine of the first angle, which is x, and sine of the second angle, which is negative y. Okay, let's just simplify where necessary. So this is going to be cos of x and cos of negative y. Notice that the angle is negative. When the angle is negative, you add 360 degrees to this. So if you add 360, it becomes 360 minus y, which is in cos's quadrant. So it becomes positive cos y. So this is cos y. And then we have plus, and this is just still sine x, but sine negative y. When you add 360 degrees to this is going to simplify to negative sine y, since 360 minus y is in cos's quadrant. So this gets multiplied by a negative sine y. And finally leaving us with cos x, cos y, and because this is being multiplied by a negative, it becomes negative sine x, sine y, and that is our answer. Question 6.1.2 says, hence or otherwise show that this is equal to tan x plus y. So we know that we're going to start using this side. So we'll say the left-hand side is equal to, and let's rewrite the left-hand side. Okay, so do you see that we have co-functions here? Cos 90 degrees minus x is equal to sine x, and this is multiplied by cos y still. Then we have sine negative y, which we know from the previous question becomes negative sine y. And then cos 180 degrees plus x, using the reduction, becomes negative cos x. And then we're going to put this all over cos x. And now we have cos 360 degrees plus y. When we have a situation like this, do you see that y is already an angle? And then you're adding 360 degrees to this. So this angle is going to be greater than 360 degrees. When you have a case where an angle is greater than 360, you can simply subtract 360 from this. So if you subtract 360, that is now gone, and all you have is y. So cos 360 plus y is simply cos y. Okay, and then that, using the reduction, becomes negative sine x, and then we have times sine y. Okay, and all we're doing here is just simplifying. So these two would multiply. Remember, they were being added and then these two became negative. So we still have sine x cos y. Then these two multiply and become plus sine y cos x. And this goes all over this, which just stays the same. But you see that this is following the compound angle identity for sine x plus y. So let's just write it in that order. Instead of writing it like that, we say sine x cos y cos x sine y. Okay, so sine y. And then here, there's nothing to really change. We can rewrite it like that. So that's going to be cos x, cos y, and these multiply and they stay negative. So negative sine x sine y. Okay, so it looks like that. And now we can finally make them equal to their compound angle identity, which this one, sine x cos x sine y would be sine x plus y. This is in your formula sheet. And you can see that is the expansion for cos. So that becomes cos and that changes to a plus like we had in the previous question. See, that is the expansion for this. So that's cos x plus y. And that's why they said hence. Okay, so now we've got sine of an angle over cos of the same angle. You know that sine A over cos A, the identity of that is tan A. So this would simply just be equal to tan of the angle that they have in common, x plus y. And that is the right-hand side, as we can see. So the left-hand side really is equal to the right-hand side. And we have proven this identity. Question 6.2 says, given f of x is equal to, and we have it equal to this, okay, which is a radical with 3 terms inside it. So we have to solve for x in the interval where x is an element of 0 degrees to 360 degrees if f of x is equal to 2. Okay, so straight away we're supposed to make f of x equal to 2. So this now becomes 2 is equal to the square root of 6 sine squared x minus 11. Now, this is cos 90 plus x. And the cofunction for this would be negative sine x. So this becomes negative sine x. And then we have plus 7. Okay, it's the only one that becomes negative, the cos 90 plus. Okay, so we still have a root, which will be a problem eventually. So we might as well just square both hand sides now already to get rid of that. And now we will have, so I'm just going to rewrite these ones over here and the 4 on the right hand side. So this now becomes 6 sine squared x, and that becomes plus 11 sine x, and that is plus 7 is equal to 4. And we can take the 4 over now. So all of this stays exactly the same and the 4 will come over. And you can already see at this point that we have a trinomial. Okay, it is not, of course, in terms of like x on its own, it's in terms of sine x, but it's a trinomial. When that comes over, it's 7 minus 4, which is 3. Okay, so here's the thing. If this is too intimidating, what you can do is you can let k be equal to sine x, which is what keeps repeating. Sine squared x, sine x is repeated. And when you do that, look at what your equation ends up looking like. It'll say 6, and we have sine squared x, so that is k squared, plus 11 sine x, so that's k plus 3. And you just have a trinomial, and you have to factorize this. So you can use the factor method, but now I'm going to use a method called the cross method. So it looks like this. We'll take the factors of the first term. Right now, just say, okay, let's say it's 6k and k. 6k times k gives you 6k squared. And then the factors of the second term, which is 3 and 1. Now, they are positive all through, so it's just going to be positive. But looking at it like this, you can see that this will not work out if the factors were like this. So here is why we call it the cross method. We multiply across, and then we check if the addition of our products end up giving us the middle term. So it needs to be equal to 11k. Let's see if that's possible. 6k times 1 is 6k, and k times 3 is 3k. Unfortunately, that gives us 9k, so this is not possible. Okay, so we need to change our factors. So don't immediately just remove everything. What we can do here is maybe change the order of this. So if this was 3 and 1, now we would have 6 times 3, which is 18, and that's already too big. So you can see that's not working. Don't change this back. Change this. So instead of 6k, we can still form 6k squared by saying 3k times 2k. Okay, and if this does not work, you can just swap the 3 and 2 and then try it again. So 3k times 3 is 9k, and 2k times 1 is positive 2k. And you see that that really does give us 11k, like the middle term. So what this means is that 3k plus 1 times 2k plus 3 are our factors. So like that, those are our factors. And now you can just replace it back with sine x. So k is sine x, so that is just 3 sine x plus 1 and 2 sine x plus 3, which is equal to 0. And now we can finally solve for x here. So here that would be 3 sine x, and you have to take the 1 over, giving you a negative 1, and then divide both hand sides by 3, giving you negative 1 over 3. Or sine x, when we'll do the exact same thing over here, would be equal to negative 3 over 2. Okay, so this is what we have, and now we just have to solve for x. Now, keep in mind the restrictions they gave us with x. They told us that x goes from 0 degrees to 360 degrees, so keep that down. Okay, so straight away, let's talk about this one, because you can see something here. This is negative 1.5. Okay, this sine graph. Sine graph, the natural sine graph, sine of x, has a range that looks like this. So the graph does this, and the highest it reaches is 1, and the lowest it reaches is negative 1. This is negative 1.5. Do you see that there is no solution for this? Negative 1.5 doesn't have any graph here anymore. Okay, so the range goes from negative 1 to 1. Therefore, this equation will have no solution. This has no solution. So we know that we just need to work with the first one. That's all. So let's go. We have sine x equals negative 1 over 3. We can use the trig diagrams to solve for this. So sine is negative, but let's focus on getting our reference angle first. So to find our reference angle, we simply just say shift sign of the positive, the absolute value of this, which is 1 over 3. So you're going to find the second function, we'll say shift sign 1 over 3 and not negative. Okay, so that gives us 19.47. Now, right now, it's okay for you to round off. And the reason why is because you see that we are solving for sine x, not sine 2x or sine a half x, something in front of x. So we do not need to divide by any number after we have found x. Okay, so that's what we'll keep as the angle, and now we can solve. So sine is negative. So looking at this cos diagram, where is sine negative? Sine would be negative in the third and the fourth quadrant. So we will use those reductions to solve for x. So we are solving for x, so solving for whatever is in front of sine. So we're saying x is equal to, and we'll use those reductions. So it's 180 degrees plus theta, meaning plus your reference angle. 180 degrees plus 19.47 degrees. And then we'll say plus k of 360 degrees because it's still the general solution so long. Or x is equal to, and then we'll use the second solution, 360 degrees minus our reference angle. So that's 360 minus 19.7 plus k of 360 degrees, where k is an element of integers. Okay, so let's go ahead and just solve for x. So x is finally equal to, and we're just going to add there. So that is going to be 199. So it is 199.47 degrees and k of 360 degrees, or x is equal to 360 minus 19 point. So that's going to be 340.53. Okay, so 340.53 degrees, and then plus k of 360 degrees. Okay, great. Where k is an element of integers, we don't even have to say that again. But we have both solutions now, the general solutions. But remember that they specifically said it needs to be from 0 degrees to 360 degrees. So here is a neat way that you can work this out. So we can use a number line just to track our answers. So the first solution we're working on is this solution for x, and we're using 199.47 plus k of 360 degrees. So in place of k, we're going to put values that are integer values, okay, just to find out where our solutions will be. Straight away, you know that if you substitute 0, you're going to have a solution, which is 199.47, okay, so 0 works. And so this is just to make sure that we don't find any unnecessary answers. Now, on the number line, if you try -1, look at what happens. You end up with -160. And this is not within our domain. It goes from 0 to 360 degrees, so it doesn't work. And if this doesn't work, you don't even have to try -2 because it's not going to work. Now, if you try 1, that's obviously going to make that way too big, so it does not work. So we know that the only solution here is 199.47 degrees. Now, with the second solution set, you see that if we try 0, it's going to definitely work. That will be within our range. So that works. 0 works. But if you try -1, it's going to make that negative, and which is not within our range. It's not from 0 to 360, so -1 does not work. 1, of course, will also not work because it's going to be too big. That is 700 degrees. It doesn't work. So you do not have to try any other ones. So x equals 199.47 degrees, or x equals 340.53 degrees. And that is our answer. Question 6.3 says, consider the function, and we have 4 minus 8 sine squared x over 3. You can see we have a common factor. Okay. The question is to calculate the maximum value of g. Now, right now, it's not very easy to see the maximum value. We would have to simplify this so that we can see it. So let's rewrite g of x first. And this is equal to, we can take out the common factor of 4 in the numerator. So that's 4. And then we have 1 minus 2 sine squared x. Okay, so over 3. Now, you can see this looked familiar. Okay, it was some number minus another number sine squared x. That, after it has been factorized, we can see that this is the identity for the double angle formula of cos 2a. So this becomes, we still have the 4 over 3, so we can write it as 4 over 3, and then that would just simply become cos 2x. Okay, and now we can see the maximum value. You see that this is cos 2x, okay? So yes, we've got 2 there, and of course the period of the graph will be changed, but it's still a cos graph. So the cos graph looks like this, and the natural cos graph, cos x, its highest point is 1, and the lowest point goes to -1. Those are the y values, right? But this has 4 over 3. So when you put a number in front of it, that changes the amplitude, and of course it changes the maximum and the minimum. So this will now go to 4 over 3, and the lowest it will reach will be -4 over 3. So that means the maximum that this graph will reach, its maximum value is 4 over 3. So therefore the maximum value of g of x is 4 over 3, and that is our answer. Question 6.3.2 says, write down the smallest possible value of x, for which g will have a maximum value in the interval where x is going from 0 degrees to 360 degrees. Interesting use of brackets here. So we need to take note of this. This has a round bracket, meaning 0 degrees itself is not included. And here 360 degrees is included. Okay, so here what they are asking us to do is write down the smallest possible value for x, but it's specifically for which g will have a maximum value. Okay, so in the previous question, I was drawing this graph of g, which is a cos graph, and it's going to look something like this, because remember, it is currently g of x equals 4 over 3 cos 2x, right? So with that being said, we know that the highest it will reach is already 4 over 3. Okay, we know that maximum value. The lowest would be -4 over 3. So it was supposed to look like this. So it has 0 degrees, 90 degrees, 180 degrees, we're just counting in 90s, so 270 degrees, and 360 degrees. because you can see that the coefficient of cos 2x is 4 over 3. The highest it will reach will be 4, just like the natural cos graph hits a highest of 1. And then that was at 0. Then at 90 degrees, the natural cos graph is 0. It's also going to be 0 here. So it hits negative 4 over 3. 270, it will hit 0. And 360, it will hit 4 over 3. Now, the question is specifically, write down the smallest possible value of x for which it will be a maximum. Look at the places where it has a maximum value. It will be a maximum here and here. But the thing is that with this graph, it's cos 2x. It's no longer 4 over 3 cos x. Okay, this is 4 over 3 cos x. That's what it will look like. When you say cos 2x, what that does is it makes the graph more narrow. So this graph would become more narrow, and everything that it had here, all these angles, they would just be divided by 2. Okay, so that ends up squeezing and looking like that. And so that means we would have another cos graph here as well, another cycle. So 1 cycle, 2 cycles, and this is what it would look like roughly. So now you can see the places it has a maximum value will be at 0 degrees, 180 degrees, and 360 degrees. But 0 degrees itself is not included because we have a round bracket there. So the smallest possible value of x where it will have a maximum between these two, the smallest one would be 180 degrees, and that would be our answer. So you wouldn't really need to draw this graph, but you could do a little diagram on this side to find this. Therefore, x equals 180 degrees, and that is our answer. Question 7 says, in the diagram below, the graph of f of x, which is equal to tan x, is drawn for the interval where x is an element of negative 180 degrees to positive 180 degrees. And note that they use square brackets, meaning these are actually included points. So negative 180 is an actual point on the x-axis. Okay, that coordinate being negative 180 degrees and 0. And the first question is to write down the equation of the asymptote of f in the interval where x is an element of 0 degrees to positive 180 degrees. Okay, so notice that that interval is here. Do you see the asymptote that we have there? It is this line. So what is the equation of that line? Well, it's a vertical line, so it's going to start with x is equal to, because it only has one particular x value that it passes and multiple y values. So its equation is x equals whatever it passes, which means it's x equals 90 degrees, and that is our answer. Question 7.2 says, write down the values of x in the interval where x is an element of negative 180 degrees to 0, for which f of x is less than or equal to 0. Okay, so let's just mark that interval. So it's from negative 180 to 0, so it's between here, okay? And we need to find where f of x is less than or equal to 0. F of x stands for the y values of your graph. So this is where our y values are negative. Okay, so let's look at that. When we look at this, where are your y values negative? Here is our y-axis. This is the positive part, and this is the negative part. So do you see down here that the part of the graph we're taking is this, because that would have negative y values. So it's all of this. Okay, so how do we name these x values? If you line them to the x-axis, you can see that they lie to the right of negative 90 and to the left of 0 degrees. So this is going from negative 90 to 0, meaning our answer is this is where x is greater than negative 90 degrees, but it cannot be equal to negative 90 because we have an asymptote there. Okay, and remember they say less than or equal to 0. So if it is equal to 0, we can include it. Okay, but less than or equal to 0 degrees. Okay, so this is our answer, but let's also think about the fact that they said less than or equal to 0. So if it's also equal to 0, we can include this. So let's look in our diagram. Do we have any other place that is equal to 0 within this interval marked in yellow? Yes, we do. Okay, so this negative 180 degrees. At negative 180 degrees, the y value is 0. And you know that this is an included point because they marked it with square brackets. So we're going to have to say this, or x is equal to negative 180 degrees. And this will be our answer. You can, of course, write these in intervals, and you can just write this one first since it is the smaller value. Okay, it's smaller than negative 90. And then if you wrote them as intervals, you would just write the negative 180 separate as well. So it will just be x equals negative 180 degrees, or, and then it's just going to say x is an element of, and we're going from negative 90, but we use a round bracket because it's not equal to negative 90 degrees, but going all the way to 0 degrees, which we'll use a square bracket for because it is included. So x is an element of negative 90 to 0 degrees. Okay, so that's how we would write that. Question 7.3.1 says, given g of x is equal to cos 2x plus 1, write down the period of g. Okay, so the period is always going to be affected by what is in front of x. That is what will tamper with your period. It will either make your graph more narrow or more spread out or wide. So in this case, the coefficient of x is 2. So this is how it works. We're going to take the period of the original cos graph. The original cos graph has a period of 360 degrees because it takes 360 degrees to complete one cycle. This will be one cycle completed in 360 degrees. And you'll have another cycle and another one, and even behind it as well. So we take that period, we say 360 degrees divided by whatever number is in front of the x, which is the 2. So this is going to be 180 degrees, meaning your graph is going to look more narrow. So instead of completing a cycle in 360 degrees, it now completes it in 180 degrees, and so it squeezes it like that. Okay, so that is our answer. 180 degrees is the period of G. Question 7.3.2 says, on the grid provided in the answer book, we'll just use the grid above, draw the graph of g of x is equal to cos 2x plus 1 for the interval where x is an element of negative 180 to 180, okay, like we have. Clearly show the intercepts with the axes as well as the coordinates of the turning points. Okay, so let's just keep that in mind. So let me get the graph above. Okay, so here is our graph. Now, remember how we looked at what this cos graph would do, okay? Because of that too, it will be more narrow. So it's going to complete a cycle within 180 degrees, meaning you will have a full cos graph here. Also notice that the number in front of the cos, the coefficient of cos, is 1. So your cos graph is going to have a maximum of 1 and a minimum of negative 1. Okay, so to understand it better, we can look at what an original cos graph would look like so that you can understand what this new one would look like. You can actually visualize what this one would look like. You know that it's going to complete this cycle within 180 degrees. So all these angles, you see how the period was divided by 2? All these angles will also get divided by 2. So with 0 degrees, it still stays 0 because 0 divided by 2 is still 0. Okay, so you're still going to have 1 there. For now, of course, because we're only looking at this as cos 2x, we'll apply the 1. And then cos 90 degrees will no longer be at 90. It's going to be at half of this, which would be at 45 degrees. Okay, so we're going to have that at 0. Then 180 degrees. You see how we had 180 degrees and negative 1? We're now going to have that at half of 180 degrees, which is at 90 degrees. So that's when you'll have negative 1. And then at 270 degrees, half of it would be 135 degrees. And we're going to have 0 there. And then at 360 degrees, that's where we have 180 degrees at 1. So that's what our cos graph ends up looking like. So like that. And then what it does here, it will also do on this side. So you have negative 45, you have negative 90, negative 135, and negative 180. Okay, like that. But then remember that our graph actually says cos 2x plus 1. So this graph is just going to shift up by 1 unit. So its maximum will not be at 1 anymore, it will be at 2, and its minimum will be at 0. So we'll shift this graph 1 unit up. So basically like that. And remember, you can always do this with a pencil. You can always plan it out lightly with a pencil and then draw it. Okay, now let's just put down those important points. We need to make sure we clearly show the intercept and the turning point. So these are our turning points, and that's also an x-intercept, and that's also an x-intercept, and that's a turning point as well. Okay, so that is what it looks like. We've pointed out all those important points. And that is that question. moving on to the next question. Okay, question 7.4 says, use the graphs to determine the general solution for this 2 cos cubed x minus, okay, so they want you to use the graphs. So it means that this will simplify to the equation of the graphs. So let's go ahead and rewrite this first. And now that we have this down, what can we do here? Well, we are at an advantage because do you see that the angle that we have is x? It's not like x and 2x, and so, we can't really do much with that. But because they're both the same thing and they're cos and sine, we can form tan, which we know we need because f of x is tan. Okay, so f of x is equal to tan x, and then g of x is equal to something with cos. So let's go ahead and take sine over. So we'll have 2 cos cube x is equal to positive sine x. And now, because we've got cos and sine, we're going to try and form tan. You know that tan x is equal to sine x over cos x. So we're going to go ahead and divide both hand sides by cos x and cos x. So this is going to be 2 cos squared x is equal to tan x. Okay, we've got the graph of f. So 2 cos squared x, how can we actually get that to look something like what we have here? So you see this one is cos 2x plus 1. So you can see that they are using double angles here. So one of the double angle expansions for cos 2x is 2 cos squared x minus 1. You can see that we have a 2 cos squared x. So if you make that the subject, you end up with cos 2x plus 1, because that will come over. The negative one comes over. And so do you see that that is actually the graph of g that they told us about? So therefore, this is equal to cos 2x plus 1 is equal to tan x. So they're basically asking you to find out where is g of x equal to f of x. Okay, and this is probably where the graph comes in. So let's look at our graphs and see where are they equal. Straight away, you can see that they intersect at 2 places, here and here. But the thing about these graphs is, you see that this is one cycle of the cos graph, right? Meaning whatever answer we get here, because this graph had cos 2x, its period was tampered with and its period became 180 degrees, meaning this answer that is here is going to repeat itself 180 degrees before this and 180 degrees after this. You see how they look exactly the same. It starts like this, it goes down and then round. This one also does the same thing, starts there, goes down and round. So this is a repetition of this angle, this answer that we have over here. Okay, so finding this one will not be a problem if we know what this is. Okay, so judging from where it is, it's between 0 and 90 degrees. So it may be 45 degrees, but we're going to have to verify this with our graphs. So what you can do is on your calculator, we're going to find cos of 2, and then we're going to find out what that is at 45 degrees. So of 45 degrees and then say plus 1. That's equal to 1, okay? Now, if the tan graph at 45 degrees is also equal to 1, then we know that that is really where they intersect because their y values are exactly the same. And of course, if we try tan 45 degrees, you see that we get 1 because the tan graph is equal to 1 at 45 degrees. So we know this is the point of intersection. So what's going on here is they really just said find, well, the general solution, okay? Not just the x values, the general solution. So because they only repeat themselves every 180 degrees and they only intersect here, this particular answer will repeat itself every 180 degrees. So the general solution for that would be that x is specifically equal to 45 degrees, but then this answer for the tan and the cos graph will repeat every 180 degrees. So we'll say plus k of 180 degrees, where k is an element of integers, and that will be our answer. Okay, and that is it for question 7. Question 8 says, in the diagram, C is the foot of a vertical building and D is the top of the same building. The height of the building, CD, is 16 meters, as we can see. Two observers are standing 19 meters apart at points A and B, where A, B, and C lie in the same horizontal plane. Okay, so that's like the ground. A painter is working at point E on the building. The angle of elevation of D from A is 46.85 degrees. And then angle DEB is equal to 122 degrees, and angle BCA is equal to this angle over here is equal to 105.61 degrees. And the first question is to calculate the length of AC, the distance between the observer A and the foot of the building. Okay, so find AC. How can we find AC? Okay, so to find AC, just look at the triangles that it's a part of. AC is a part of this triangle, yes, but it's not a good idea to use this one right now because the only thing we have are these two. Okay, AC is missing. You don't even have this angle here, so we cannot even use the sine rule here. So we can focus on this triangle. We have a right angle triangle. We have one side in the triangle and one angle, so we have more than enough. So we can see from this that AC in reference to the angle is the adjacent side. It's next to this angle. And then the only other side we have would be 16. In reference to this angle, that is the opposite side. So we have an opposite and an adjacent side. So which function will we use? We will use tan. So we say tan of our angle, which is 46.85 degrees, is equal to the opposite side, which is 16, over the adjacent side, which is AC, and that's what we're looking for. So all we have to do now is make AC the subject of this equation. You can do so by cross multiplying or by transposing. So you see this says divided by AC on this side. When it goes over, it's no longer going to be in the denominator, it will be in the numerator, AC. And this one, right now, it's actually on the numerator because there's an invisible denominator of 1. So when it goes over, it will go to the denominator. So you'll still have 16 here over tan of 46.85 degrees. And we just have to find this. So that's going to round up and add a 1 there, add a 1. And so it ends up just being 15 units. And that is our answer for AC. Question 8.2 says, calculate how far the painter at E is from the top of the building. So how far the painter at E is from the top of the building. So that is the line ED. That's what we need to find. Okay, so knowing now that AC is 15 units, how do we find ED? Do you see that ED, for you to find ED, you would need to know what EC is, since we already know what AD is. So if you take AD and you knew the length of EC, if you say AD minus EC, you will get ED. So the main goal here would be to find ED, you need to find EC. Okay, so how can we find EC? Well, EC is part of a right angle triangle, which is great. With the right angle triangles, like you saw with this one, all you need is an angle and an available side, and then you can find another side in the triangle. So you see that because it's a right angle triangle, in the previous triangle, all you need to find a side is an angle and another side. If this is a right angle triangle, you'd be able to find another side. So we would just need an angle and another side. Do you see that we can easily find this angle? Okay, since this measures as 122 degrees, and so these are the angles on a straight line. So we just need one side here. Let's see which side we can actually find. So EB is definitely out of question because it's just way off. But then BC is one of the shared sides with this triangle on the bottom. So we could try finding BC. How would we find BC? If we're looking for BC, what we could do is we could use the sine rule. So to use the sine rule, we have this side, and then you would have to pair this with the angle opposite that side, which is this angle here, CAB. So we need angle CAB. You see how we travel throughout this diagram, how we initially needed ED, but then now we need EC, and now we need BC, and now we need this angle. Okay, so to find this angle, we could focus on finding this angle. Okay, if we find this angle, we'll be able to find this angle. Now, here's why we can find this angle. Because we have 15 over here. This is 15 units, and we have this that we're looking for. And then we can pair that up. So long, let's just leave this. We can pair that up with this. So we're going to use the sine rule here. Because we are looking for an angle, make sure you put the angle first. So this is how we can write this. We'll say sine of this angle B, but it's actually angle ABC. So let's just call it that. We'll say sine of angle ABC over, and then over the side that it's opposite. That angle is opposite that side AC, which is 15 units. So over 15 is equal to, and then you need to pair it with another side in the same order. So sine of an angle. So you see how this is already complete. We've got the angle and the side. So we can say sine of 105.61 degrees, sine 105.61 degrees over the side opposite it, which was 19 units. So we can use this to find angle ABC. You see that the only way we can solve for this is to get rid of this 15. It's on the denominator now, so if you transpose it, it's going to be on the numerator. In other words, you can multiply both hand sides by 15. So sine ABC is equal to 15 sine 105.61 degrees over 19. And then to solve for this angle, you can use the second function of sine. It's kind of like taking sine over. So ABC is equal to, it's going to become shift sine on the calculator and then everything here. Okay, so the angle ABC is currently just 49 points, but I'm not going to round off. I'll just leave it like this for now. And then anything else that we have to calculate, we'll just have to calculate by ourselves. Okay, so we've got ABC. The main goal here is not to lose track of what you were trying to do. So since this was just 49 points, we'll call it 49.5 for now. Since we have this, we can finally use that to find this angle. That's what we were looking for, because this angle will help us to find BC, and BC will help us to find EC. So you see that you can simply just use the angles in a triangle. The angles in a triangle add up to 180 degrees. So this angle BAC is 180 degrees minus this angle and minus the 105.61 degrees. Okay, so on our calculator, we can simply just say 180 degrees minus the 105.61 minus our answer that we had. And we'll hold on to this and make sure that we don't round off. So I'll just call it 8945 and I won't round off yet. Okay, so this angle, and we might as well just leave that one like the way it was supposed to be. Okay, so as 49, and this one, we can just go ahead and call that 24.89. Okay, it's just for us to understand where we are going. Okay, so now that we have this, we can find BC. And we will find BC using the sine rule. So we want BC, so we need to use the angle opposite it as well, and then take another pair that is complete. It's safe to take these ones since this was already rounded off, okay? So we don't have to overthink using this. Okay, so this time, BC is what you're looking for. You're looking for a side. So we're going to ensure that we put that side first using the sine rule. So it's going to be BC over sine of the angle opposite it, which was sine of this angle that we currently have, which is equal to, and we're going to just take this pair, the 105.61 and 19. So it's equal to, you have to follow the same order. So side over the sine of the angle. So sine of 105.61. Okay, and now to make BC the subject, you see that this is the only thing in the way, and it's in the denominator. So to get rid of it, you multiply both hand sides by that same thing. So what will happen is it will move to the numerator, and now we have BC is equal to 19, and then sine 24 points. We won't round off, we'll just use that as ounce over, and then sine of 105.61. Okay, so BC is now equal to 8.3043. Okay, we still won't round off. And let's just see, now that we have BC, we can finally find, so this is 8.30, we can finally find EC. So do you see that this is part of a right angle triangle? So we just need one single angle and we'll be able to do this. Okay, we can either use the rule that these add up to 180 degrees or that this is the exterior angle of this triangle. So the exterior angle of a triangle is equal to the sum of the two opposite interior angles. But it's easier to just use the angles on a straight line. So what is 122 degrees, 180 degrees minus 122 degrees? Is 58. So we know this is 58 degrees. Okay, so that was just the only little calculation we would have needed to do without a calculator. So that is 58 degrees. And now this is very helpful. So we can just also note down that BEC is equal to 58 degrees. Okay, that is BEC. And now let's go ahead and see what we can find here. So we've got an angle, we've got a side, and we can use this to find EC. So relative to this angle, EC is where? EC is next to the angle, so it is the adjacent side. Okay, the adjacent side is next to it. And then BC, the only other side we have to use, is opposite that angle. So we just have to find their positions. So we know we are using opposite and adjacent, and that is TOA. So we know we are using tan from SOHCAHTOA. So we'll say tan of 58 degrees is equal to opposite over adjacent. So 8.30 over EC. Okay, so you see that as we have this now, to get EC to be the subject, you could multiply both hand sides by EC, but you could also just transpose. So you'll have EC is equal to, and then you want this to leave so that EC is on its own. This is currently on the numerator because it has the natural denominator of 1. So this is still in the numerator, 8.343. And then we're going to say, that's not degrees, that's a side. Okay, and that's going to be tan 58 degrees over tan 58 degrees. And let's find EC. And EC, and this is the point where we can round off, because EC is just the last length we're trying to find to help us to find this. This is already a whole number, so you just have to round off to whatever rounding we need to work with. The exam paper says round off to 2 decimal places unless stated otherwise, so we will round off to 2 decimal places at this point. So that makes EC equal to 5 points, and that adds a 1 to the 8, so 19. Okay, so that's what EC is, and these are in meters. Okay, we should have also said that for BC. This is meters. Okay, so now that we have that, we can finally find this. So we were looking specifically for the length of ED, and you can see now that to find ED, you will simply take the entire length of DC and then say minus EC, and that will give you ED. So ED is equal to 16 minus 5.19, and that will be ED. Okay, which is just going to be 10.81 meters, and that is our final answer. The length of ED is 10.81 meters. Okay, and that is it for question 8. Question 9, and they already make a statement. Provide reasons for your statements in questions 9, 10, and 11. Question 9 says, in the diagram, ABCD is a cyclic chord. BC is produced to E, AC is drawn, and then they start telling us these, which is going to be important. Angle A1 is equal to a half of angle B. Okay, so whatever angle A1 is, it's half the size of angle B. Okay, so this will be the bigger angle, and that's the smaller one. So if, for example, if this is 20 degrees, then that is 10 degrees. Okay, A1 must be half of B. And then angle A2 is 46 degrees, and angle C1 is 86 degrees. And the first question is to calculate with reasons the value of angle A1. Okay, so how do we find angle A1? Do you see that we have an exterior angle? We have an exterior angle in a cyclic chord. The exterior angle is always equal to the opposite interior angle. So it means angle A1 plus angle A2 would give you this exterior angle of 86 degrees. And that's what we're going to do. So Angle A1 is what we're looking for. Angle A2 we have as 46 degrees, and that should give us 86 degrees. And then we'll put our reason, exterior angle of a cyclic quad. Okay, and therefore angle A1 is going to be equal to, if you take 46 degrees over, so 86 minus 46 is 40 degrees, and that is our answer. Question 9.2 says, hence, prove that AD is equal to DC. So we have to prove that two lines are equal. So we need to prove this is equal to this. Okay, so that would mean that this should be an isosceles triangle. And something else we know about isosceles triangles, apart from two sides being equal, is that two angles will be equal, specifically the angles opposite these equal sides. So this should be equal to this angle. Okay, I'm not saying they're equal yet. We just need to show them that those two angles are equal. And if we can show them that, then it automatically means that these two sides are equal. Okay, we are working with numbers here, and we do know the size of angle A1. It's 40 degrees. We found that in the previous question. What we need to find is angle C2. If we can find that angle, it should be fine. Now, looking at it like this, you can see that we have an exterior angle. But this is not very helpful, because if this is your exterior angle of this triangle over here, you would need this angle for you to even find out what that is. And we don't really know what this angle is. But they also leave some information here. So let's look at what they say in the top. They say angle A is equal to a half of angle B. Specifically, they said angle A1 is equal to half of angle B. So we have that. Angle A1 is 40 degrees. If angle A1 is 40 degrees, then it means that angle B must be 80 degrees. Okay, so let's put that down. Angle B is therefore equal to 80 degrees. Okay, so we can just tell them, given that A1 is equal to half angle B, so we know that that is 80 degrees. And now this actually helps us. We can now use the exterior angle of a triangle to find angle C2. So we're saying that this angle, because we have this triangle over here, the exterior angle of a triangle will always be equal to the sum of the two opposite interior angles. So add this angle with this angle, and you should get this entire angle, which is 86 degrees plus angle C2. Okay, so 86 degrees plus angle C2 equals 80 degrees plus 46 degrees. That's what we have over here. Okay, and the reason for that is the exterior angle of a triangle. Okay, so let's go ahead and solve for angle C2. Angle C2 is just equal to these two added and minus 86 degrees. Okay, so which is equal to 40 degrees, because you can just cancel 80 degrees from both sides and you have 6 degrees. You take it over. 46 minus 6 is 40 degrees. Okay, so there we go. We found that this is equal to 40 degrees. So if angle C2 is also equal to 40 degrees, do you see that we have equal angles? So it would mean that the sides opposite those equal angles must be equal. Okay, angle C2 equals angle A1. Therefore, that means that that line AD must be equal to DC or CD. So let's say AD equals DC. And the reason for that would be, so you see how when you have a triangle and they tell you that two sides are already equal, then you can show them that these two angles are equal. And the reason for this would be angles opposite equal sides are equal. That those angles lie opposite equal sides, therefore they are equal. But you can see in this case, we found that the angles were equal, and we are proving that because of that, the sides are equal. So this would really be the inverse of that. So it's the sides opposite equal angles that are equal. That will be our reason. Okay, so there we go. We have proven that AD is equal to DC. And that is it for question 9. Question 10.1 says, in the diagram triangle, RST is drawn, and then we have line AB intersects RS and RT at A and B respectively, such that AB is parallel to ST. Prove the theorem which states that the line drawn parallel to one side of a triangle divides the other two sides proportionally. And they specifically are showing you that they want you to prove that RA over AS is equal to RB over BT. Okay, so with this proof, we first have to sketch down some construction lines. So to prove this theorem, focus on RA and AS, but we're going to focus on them as the bases of our triangles. Okay, so RA as a base of a triangle, if you're looking at this as that is the base, you need a perpendicular height. We're going to sketch the perpendicular height. So the idea behind this is you cannot use the proportionality theorem, but rather we're going to prove it. So we are going to use the areas of triangles. You see how RA and RB are both the bases? They can both be the basis of this triangle. Okay, so let's go ahead and start sketching. We will draw a perpendicular line from point B all the way to RA. So it goes like that, and it's going to be a dotted line, of course. And we can go ahead and call that H. So it's perpendicular to RA, and we can call it H. And then we'll draw another perpendicular line because we're going to look at RB as if it's the base of a triangle as well. So it's going to need a height. So the height of RB is going to go from A down and it's perpendicular to RB. And we can call that K. That's fine. Let's call that K. Okay, so we've got heights in that triangle. And so we're going to look at that as that's the base and that's the base. And those are their respective heights. Okay, now we're also going to use some triangles down here because you see that we have AS and BT. So we're going to look at that as the base of the triangle. But the triangle that we're going to draw here is by joining B and S. So if we join these two and then we'll make them construction lines. And you see how that forms a triangle with the base AS, but it has the same height as this triangle over here with the base RA. And then we'll do the same for this height as well. We'll draw another triangle that shares this height down here. So by connecting A and T, and then make those construction lines as well. And again, this triangle has a base of BT and it is sharing this height of K. Okay, so now we have to just write down all the constructions that we have made. Okay, so now focusing on these triangles, we will focus on these sides as the basis of the triangles. And we're really just trying to ensure that RA goes over AS. So we're going to use their areas. The area of the triangle with the base RA and the area of the triangle with the base AS. Okay, so that's going to be this triangle RAB. And the second triangle we're going to have there would be this triangle ASB. That's the one with the base AS. So it is the area of the triangle RAB over the area of the triangle ASB. Okay, and this is not equal to anything. It's not equal to any area over another area yet. We're just simply finding it and finding what it gives us. We know that the area of a triangle is equal to a half times the base times the height. So let's look at the base and the height here. In this triangle on top, the base is RA. We're trying to ensure that that is the base. And the height is H. So this is equal to a half multiplied by your base, which is RA, multiplied by your height, which is H. And this goes over this triangle ASB. Looking at that triangle, this is the base, but do you also see that this is the perpendicular height? Because this is the highest point of the triangle. And if you go down to the perpendicular line, which is an extension of the base, then that is the height. This triangle is really just an obtuse triangle and it's actually skew, and this is the height. Okay, and do you see at this point when we do this, we're going to have things cancel here. So these two, the half and half would cancel, and the H and the H would cancel, leaving us with RA over AS. Okay, great. Now we're going to do a similar thing with these bases now. Okay, so we're trying to ensure that these are the bases of the triangles that we're focusing on. So again, with this one, because it's the same triangle, it's the triangle RAB, the area of triangle RAB over the area of the triangle ABT. Okay, and then this is equal to, again, a half times the base. Now, the base here in RAB, we are focusing on RB as the base, and the base here is BT. But you can see their common height is K, just like we had with the H as well. So that's a half times RB times K over a half times, and then the base here would be BT instead. So a half times BT times K. Okay, so a half and a half would cancel, and K would also cancel because they're exactly the same. So this is now equal to RB over BT. Okay, great. We have those individually. Now, to make them equal, or really to prove that they're equal, we're not making them equal, we're only proving. With the first triangle, you see that triangle RAB and triangle RAB are exactly the same. So we can state that for them. So the area is exactly the same. So you can just say, therefore, area of triangle RAB is exactly the same as RAB since it's the exact same triangle. But here is the thing about the bottom ones. These bottom triangles, do you notice that it's this triangle over here and this triangle over here? These triangles lie between parallel lines. So, since they lie between parallel lines, they would have the exact same height. Okay, so if you extended this and you went from the highest point of the triangle and you went down to an extension of the perpendicular base, okay, an extension there, then you see that the height would be exactly the same over there as well. But that's not the only thing that is the same in these two triangles. It's also the base. AB is also exactly the same. So since they have the same base and height, their areas will be exactly the same. So we're just going to state that they're equal and tell them it's because of their base and their height being equal. So triangle ASB is exactly equal to triangle ABT because they have a common base. They were sharing a base, okay? As you can see, AB was the base now. And they have the same height since they lie between parallel lines. And I just make sure to state those lines that are parallel. Okay, so if we can see that those areas are equal and those areas are equal, and we know that when we found RAB over ASB, it gave us this, and RAB over ABT gave us that, that means that we can therefore say their areas put over each other exactly the same. So we're really just taking this and we're saying it is equal to that as well. And since their areas are equal, we can therefore now conclude what they simplify to would be equal. This is finally equal to this. Okay, so their ratios will also be equal. So this will be RB over BT. And when we look at what they told us to prove, do you see that it's exactly the same? Prove that RA over AS equals RB over BT, and we have proven this. And that is it for 10.1. Question 10.2 says, in the diagram, O is the center of the circle. And then we have triangle PWS is drawn, and we have P, W, and S on this circle. So they're on the circumference of the circle. Then we know that OR is perpendicular to PS and PRS is produced to T. SW and OT intersect at V, so those lines just intersect at V. And then they give us some important information here. So they tell us that OV is to OT is 1:4. Let's go ahead and put those ratios down. When they put these ratios down, it's the same thing as them giving you this as fractions, really, okay? They're just saying if you took OV over OT, it gives you 1/4, meaning OV gets 1 part and then OT gets 4 parts. So we can actually put that down here. So OV is going to take 1 part, meaning we can just call that A. So that is A. And then OT gets 4 parts. So this is A. And then that one can be 4A. Okay, so we've put that down. The first question, 10.2.1, is to prove with reasons that OR is to WS is equal to 1:2. So this is a half, okay? Meaning OR over WS equals 1/2. OR is here, this, over WS. Interesting. Okay, so the minute they say that, they're saying this one will get 1 part. So let's say K, and that would get 2 parts. So let's just see how that is possible here. Okay, so at this point, we can actually see this because this is the center of the circle, this is a radius, and this is also a radius. So these two would be equal. And then here, do you see that we have a line from the center of the circle perpendicular to the chord? The line from the center of a circle perpendicular to a chord will always bisect the chord, meaning PR is equal to RS. And that's what we have there. So this is the midpoint theorem when you have this side being equal to this side and that side being equal to this side. Therefore, it means that the two lines are first parallel, and secondly, this OR will be half the size of WS. Okay, so we just have to write down everything. So let's tell them that OP and OW are equal, and the reason for them being equal, okay, because they are equal radii. And then these two are equal because of the line drawn from the center of the circle perpendicular to the chord. So therefore, this means that OR is half the size of WS. Okay, so we will say OR is equal to half the size of WS. And the reason for this is when we have that case, it's because of the midpoint theorem. So we have to state that. Okay, so remember that this is what they want you to prove in this order. If you're saying that OR is equal to half the size of WS, then this means if you put them over each other, you could just decide, let's go ahead and divide both hand sides by WS so that it looks like that, OR and then WS. So this is simply just going to be OR over WS is equal to a half, meaning OR is to WS is equal to 1 is to 2. And there we go. See, the same way we're able to express these ratios as 1 over 4 is the same way we're able to do that here. And that is answer for 10.2.1. Okay, 10.2.2 says calculate the length of PT if ST is equal to 15 units. So they want us to find the length of PT, this entire length, if we know that ST is 15 units. 15. Okay, let's get rid of these ones. And here, do you see that we are using proportions here? Along with proving that this is half the size of this length, we also would conclude that these two lines are parallel. So, do you see that to find the entire length of PT, because we already know what ST is, we just need this part. But the good thing about PS is that PS is made up of PR and RS, which are exactly the same length. So we can just focus on finding RS. If we find RS, we have found PR and therefore PT. Okay, so let's go. Because we've already put these down, it makes it much easier to find. So focus on finding RS. So we're going to say RS, and we can take it over another side that we do have, which would be ST. So RS over ST, and using the proportionality theorem, this is going to be equal to, since we took this, we'll have to take OV over VT. Okay, let's just get this straight with VT. Do you see that OV is A, one part, and VT would not be 4A. OT is 4A, meaning VT must be 3A, because you would say A plus 3A to get the full 4A. Okay, so let's just keep that in mind. So it would mean that we can use these proportions and we must make sure it's equal to the correct ratios. Okay, so RS over ST equals OV over VT, which we can say is the line parallel to one side of the triangle or the proportionality theorem. It's perfectly fine. Okay, and in doing so, just ensure that you state the lines that are parallel. So these two lines are parallel, OR and WS. Okay, so we know that we're looking for RS, so that one stays RS. However, ST is 15 units, that's 15. And we know that OV took one part of that line, and then VT took 3 parts, as we saw previously. So now we can finally solve for RS. So to solve for RS, get rid of the 15 by multiplying both hand sides by 15. So RS would be equal to, that 15 goes here, so it's really 15 over 3, which is equal to 5 units. So if RS is equal to 5 units, then we can use that to find PR since they are equal. We've already stated that they are equal, so we can also just therefore say this also means that PR is equal to 5 units because this is already proven. So if RS and PR are both 5 units, so that's 5 plus 5 plus 15, and so that gives you 25 units. So we can finally conclude that it's going to be equal to 25 units. Therefore, PT is equal to 25 units, and that is our answer. And that is it for question 10. Question 11 says, in the diagram, A, B, G, and F lie on the larger circle. A smaller circle is drawn to touch the larger circle internally at A. So we have that circle over there. EA is a common tangent to both circles, as you can see with the bigger circle and the smaller circle. EBCF is a tangent to the smaller circle. So that is that over there. That's a tangent to this circle only. And of course, it's a tangent at C. AC is produced to G. AF cuts the smaller circle at D, as we can see there. AF just cuts in there. And A, B, C, D, and GF are drawn. So these are just lines that are drawn. Question 11.1 says, if EAG is equal to X, determine with reasons 4 other angles that are equal to X. So EAG is this angle over here, E to A to G. So this angle here is X. 4 other angles that would be equal to X. Okay, so they already put EAG where we have a tangent, okay, the tangent to both circles. So we can use it like that. If this is a tangent to both circles, then all that means is the angle between the tangent and the chord, let's use the smaller circle first, and the chord in the smaller circle would be equal to the angle supported by that chord, and that would be this angle D1, see, supported by that chord. So we can go ahead and start with that. We can tell them that angle D1 is equal to angle EAG, so EAG, which is therefore equal to X. Okay, so wherever we find these, we should just put down X so that we know that we have found that. So this is now also X. Okay, where else? Because it is a tangent, a common tangent to the smaller and the bigger circle. So it's the angle between this tangent and the chord in the bigger circle that is equal to the angle supported by that same chord. So this angle AFG. So that is what will be equal to X. And we can just note that down as well. So it's also equal to EAG, which is equal to X. And both of them are because of the tan chord theorem. So we'll just also put those reasons down. Okay, let's see what else we can see in this diagram. So, given everything that we have don't have a diameter, we don't really have radii, nothing like that. However, we do have this. So, remember how this is a tangent, but we also have another tangent to the smaller circle. This EC is also a tangent, and we know that tangents drawn from the same point are equal. So, if these two lines are equal, then it means that the angles opposite their equal sides, that angle and that angle, are also equal. So that would prove that angle C1 is also equal to X. So with this one, let's go ahead and state the sides that were equal that made these angles equal. So AE is equal to CE first, and that is because of tangents from the same point, okay? So tangents from the same point are equal, therefore these two angles are equal. Angle C1 is equal to angle EAG as well, which is also equal to X. And the reason for that would be angles opposite equal sides are equal. Okay, so that is the third one that is equal. And then we need one more. Okay, so this one is quite simple. You see how these lines cross, they intersect like that. So we have vertically opposite angles. So angle C4 is also equal to X because it's equal to angle C1. So we can just tell them that angle C4 is equal to angle C1, which is also equal to X. And this is because of vertically opposite angles are equal. So vertically opposite angles is fine. And there we go. Okay, we've got 4 angles that are equal to X. And you just need to make sure that it stays in the diagram because it will help you with the next questions. Okay, and that is it for 11.1. Question 11.2 says prove that AG times AD equals AC times AF. So what we have to do here is just find those lines so that we can make sense of it. So AG is this line over here. AD is this line over here. AC is this one and AF is this. So from that, you can clearly see that they use the proportionality theorem. For them to have used that, it means that CD has to be parallel to GF. So can we see a solid reason why those two will be parallel? Yes, okay, angle D1 is equal to angle F that. Okay, it's not really F1, but it's AFG. So since they're equal, what we actually have there are corresponding angles. If you have corresponding angles and they happen to be equal, it makes your lines parallel. Okay, so let's go ahead and state that first. Okay, so there we go. AFG equals angle D1, which is still X. And therefore, those two lines are parallel, CD and GF, because we have corresponding angles that are equal. Okay, so now that they are parallel, we can go ahead and use the proportionality theorem because we can see from the lines they are using, they clearly use that theorem. So we're going to take AC over AG and we'll say that is equal to AD over AF, and it's because of the proportionality theorem. And then we can just tell them this is because of the proportionality theorem or prop theorem. Okay, now we just have to make it look like that. So do you see that they just cross multiplied? So they said AG multiplied by AD, and then they got AG times AD is equal to, and then they multiplied across like that. So AC multiplied by AF. And there we go. That is just the conclusion. We're finally proven what they asked us to prove. Okay, and that is the answer to 11.2. Question 11.3 says, prove that triangle AGF is similar to triangle ABC. So let's go ahead and mark these triangles. So here is triangle AGF, and then triangle ABC is this one over here. How can we prove that these two triangles are similar? Okay, so first we can see that they have an equal angle, X and X. However, if you look at it like this, look at AF. This is a chord that is supporting angle B2 and angle G at the circumference of the bigger circle. So they would be equal. Okay, so you already have two angles equal in these triangles. Therefore, the third angle by default will be equal. So there we go. That's how we would prove that. So let's introduce our triangles first and then get on with proving it. So in triangle AGF and triangle ABC, and we're going to state everything that is equal. So we first know that angle C1 and angle AFG are already equal since they're both equal to X. And let's state that. And this has already been proven. So we can just tell them it's been proven. And then what else? We had these two angles being equal. This is equal to this because of the angles in the same segments are equal. So let's go ahead and tell them that, and I'm going to name the bigger one first. So AGF is equal to angle B2. So AGF equals angle B2. And that is because of angles in the same segment. Okay, and now that we have that, we can also just finally conclude that the third angle in each triangle would be equal by default because the sum of angles in a triangle must add up to 180 degrees. So if those two are already equal and those two are already equal, then by default, the remaining two will be equal. So angle A2 would be equal to angle A3. We can tell them that angle A3 is therefore equal to angle A2. And this is because it is the third angle in a triangle. Okay, and that proves that they are similar since their corresponding angles are all equal. So triangle AGF is therefore similar to triangle ABC. Okay, and the reason they are similar is because of angle, angle, angle. Three sets of angles that are equal. And you have to state this because this is not the only way that triangles can be similar. They can also be similar if their sides are in proportion. But they didn't give us any length, so we don't have to focus on that. Okay, so that is it for 11.3. Moving on to the next question. Question 11.4 says, prove that GF squared is equal to BC times FC. So when you see these kind of things, we're going to have to find out where these lines are coming from. So let's get our diagram and make sure to update it. I've already updated this diagram. So you see that these two are equal. We have all the x's that are equal there. And these two angles, A2 and A3, are equal. So looking at that, let's just see the sides that they are using. So we have FG or GF squared, meaning it was used twice. Now it's over here. The only two places it could have been used is in this triangle here and in the bigger triangle, because do you see that in those two triangles, it is one of the sides of those triangles. Okay, so we'll look at it as it was probably used for those two triangles. And then we have BC. So BC is over here. And this was probably used because of this triangle ABC. And then FC, let's just see, FC is over here. Okay, so it seems like they use this little triangle. And then AF is over there. So we can see that the bigger triangle was also used, definitely. And then we have AD as well. So AD, where does AD fall? AD is just here. So they probably used this triangle. Okay, with the triangles that we're looking at, you see that these triangles have a lot of similarity. See, we already know that these two triangles are similar. And we know by default, okay, because of the proportionality theorem, we know that these two triangles will be similar. Okay, these two, they will definitely be similar because we have corresponding angles and a common angle, angle A3. And now we can also see that these two would be similar. See, like that, because they have vertically opposite angles. They've got these two being equal, and they've just got a third angle. Okay, so all three would probably be similar, and then we'll see how we can get those dimensions. The previous question usually has a lot to do with the next question. Let's look at the previous question. Does it have sides that we need here? The previous question was using AGF and ABC. Looking at those sides, you see that we have FG. We actually do have that. That is something that we should look for. But here, the FG goes with BC. Okay, do we have BC here? Yes, it's also one of the sides that is highlighted. Also see that AF as well and AC. Okay, AC is not really needed, but we do need AF. So that may be helpful. So we can use those proportions over each other. Let's just see what we get with that. So my plan here is actually to take advantage of this GF because it appears twice. If we could get dimensions that include GF and then make GF the subject in each, then multiply them together to get GF squared, then this could end up being a scenario that we have. But of course, we're going to have to carefully monitor it so we don't have to, do a whole trial and error. Okay, so because this one has FG, which is something we're looking for, we need that twice. Let's go ahead and use that. So we're going to say, to use it like this, we can say FG or GF, right? So it was GF here, we can leave it like that. GF, so when you take the second and last, you have to take the second and last in the second triangle as well. So GF over BC would be equal to AF over AC. Okay, so the reason was because we had those two being similar. Okay, so now let's go ahead and make GF the subject. So we have GF is equal to, and if you take BC over, it'll go to the numerator. Okay, just transpose it. So it is AF times BC over AC. Okay, we'll monitor this. The thing about AC is we don't really need AC because it's not one of the sites highlighted. It's not one of the sites that was included here. So we have to find a way to get rid of AC. And the only way to get rid of AC is to get another side with AC. Okay, but depending on where AC is, it can cancel. For example, if you had AC over something times something over AC, they would cancel. So it's not necessarily that big of a problem as long as we just get something with AC that can help to cancel that one. Okay, now let's just compare this with what we're supposed to prove. We've got 1GF. That is great. Okay, we've got 1GF. We have a BC, which is what they also have, a BC. And FC we don't have. So we need to find something with FC. And AF, we actually do have AF. So AF is there. And AD, we do not have AD. So let's look for a triangle with FC, AD, but remember they should still be GF and AC in it. So these are the sides that we're looking for. We're looking for a triangle with FC, with AD, with AC, because it needs to be able to cancel that one there since we do not need it. It's not in here. And we need another GF to create GF squared. So we need GF. Let's see. Are there any triangles that fit these? Okay, so let's just remove these and just see. We need an FC. So FC is this. We need an AD here. We need an AC. So you can already see this triangle is probably involved. And GF. We need a GF. Okay, so it's these two triangles that we can actually use to form this. We can use this triangle here and this triangle here. For us to be able to use them together, to use their proportions together, they need to be similar. Okay, so they are actually similar. As you can see, we've got an X, we have an X. And then we actually have two angles equal to each other here because these are corresponding angles, okay? They form an F with the parallel lines. So we have two angles equal to each other there. And then the third angle will be equal by default. So we can state that these two are similar because they have corresponding angles that are all equal. Okay, they never asked us, we're not proving that the triangles are equal, we're just showing them that they are and giving them a reason for that. Okay, so let's just ensure we name it in the correct order. You see the black line and the black line together and the red and the red. So if you named it as DCA, then you need to name this as CGF. Or we can just call it ADC and FCG. That's fine. Okay, so triangle ADC is similar to triangle FCG, and that's because all their corresponding angles are equal. Okay, so with these, we know what we're looking for. Let's just focus on those. We need one with FC. Okay, there, we've got one with FC. So if you take FC, by default, you need to take the side that corresponds in this triangle. That's the first and second letter, so we also have to take the first and second letter. So this is going to be AD over FC. Okay, and this is equal to, let's find out what it's equal to. We also need AC and GF. So let's focus on getting the GF. If we take GF, do you see that GF appears here? So you have to take the first and second letter with the first and second letter, and that actually works out perfectly. So this is equal to, and we can just follow that. That's going to be AC over FG. Okay, let's go ahead and we can call it GF just to make it the same. Okay, now we can go ahead and just make these the subject. So make that the subject. This is already the subject here. And then we're going to multiply them together. Okay, so now we can just cross multiply. It's better to cross multiply so we just avoid any mistakes. So we need GF multiplied by AD is equal to, and then FC times AC. So FC times AC. And then we'll make GF the subject because we just want that to be on its own. So we'll divide both hand sides by AD. So GF is equal to FC times AC over AD. Okay. And now we have GF as the subject. Okay, so now we can form GF squared. So we can go ahead and call that equation 1. And that's our second equation. And we're multiplying them. So equation 1 times equation 2. And so that's going to be left-hand side times left and right times right. So that's GF times GF. GF times GF is equal to, and then we're taking all of this multiplied by the right-hand side of GF in equation 2. Okay, so there we go. So this is therefore equal to, so we have GF squared is equal to, and you see here that AC, the AC that we were trying to get out, by adding another AC that would be in the numerator, we would cancel that, okay, because they would multiply. And then now we can just put it in the same order because now we have the same things. So we have BC, FC, AF. So there's BC, there's FC and AF. So we'll say BC times FC times AF all over AD. And that is our answer. So there we go. Okay, so that one always takes a little bit of thinking, but that is one way we can solve it. And that is the end of question 11. Okay, so that is it for this paper. I hope you guys enjoyed it, and I will see you guys in the future videos. Bye!